Hello and welcome to my physics classes. My dear students, I hope you all are fine and doing well. Hard labor does pay, but smart study is the key of success. Now let us begin with the solution from question number 10 of rest and motion kinematics. The question is written here. From the velocity time plot shown in figure, find the distance traveled by the particle during the first 40 seconds. Distance during the first 40 seconds. Also find the average velocity during this period. The graph is given here. It is very easy question. You know very well that the VT graph, area of VT graph represent distance and displacement both. But if you add this area plus this area, then that will give distance. And for displacement, this area minus this area, that will give the net displacement. Okay. So here, this is in positive quadrant, the first quadrant, this is in fourth quadrant. So now, the first question is, in first 40 seconds, this area plus this area, both area you are looking here are same. Therefore, distance is equal to distance during 40 seconds. That will be equal to 2 into area of one of the triangle. That is half into 20 into this height. 20 into height, that is 5. 100 meter is the distance. The area of this plus area of this, and both area are equal. Therefore, I have written here 2 times one of the area of the triangle. Now in second case, in the same period of time, that is in 40 seconds, what would be the average velocity? What would be the average velocity? Average velocity V is equal to total displacement by total time. Total displacement by total time. Total displacement is 0 here. 0. This displacement, total displacement, this distance minus this distance. Total displacement will be 0. This area minus this area. 0 by 40, that is 0. So 0 meter per second will be average velocity. Now, second question. Next question, that is question number 11. I think you have got it. Okay. You can write by pausing the video also. Okay, now question 11. Question 11. Question 11. What it says? Question 11 says, figure shows, here figure number written 3E6. Figure 3E6 shows xt graph of a particle, position time graph, xt graph of a particle. Find the t such that, find the time, that is time t, such that the average velocity of the particle during the period 0 to t, during the period 0 to t is 0. The graph is shown here. 10, 20. It is 10, 20 here. From here okay, it is in x in meter, and t is in second. This is origin. We have to find average velocity of the particle during the period 0 to t. 0 to t is 0. 0 to t is 0. Average velocity is what? Solution. Average velocity is equal to total displacement by total time. Total displacement here. From here to here. Suppose this point is, this is of the same height. This height from here to here, and it comes from here to here, and again it reaches the same height. That means this height, it decreases from here, comes here, again increases, and I think approximately it comes at 12 seconds here. If you draw the graph on your graph paper, then you will find this point will tally to this point, that will indicate 12 seconds. So here from 0 to 12 seconds, this displacement from here to here, and again same amount of displacement in opposite direction from here, means total displacement becomes 0. 0 by total time 12 seconds, that is 0. And time will be 12 seconds. Okay, I think you have got it. Now question number 12. Question number 12. Question number 12. A particle starts from a point A. A particle starts from a point A. Starts from a point A and travels along the solid curves. And travels along a solid curve shown in figure 3E7. Find the approximately the position B find the approximately the position B, approximately the position B of the particle such that the average velocity between the points A and B, the average velocity between the points between the positions A and B has the same direction as the instantaneous velocity at V, as the instantaneous velocity at V. The graph is shown here. 2, 4, 6 meter, 2 meter, 4 meter and 6 meter. 2 meter, 4 meter from A to this is point A, y-axis, x-axis. This is given here. The particle such that the average velocity between the positions A and B has the same direction. A and B. A is given. B is a variable point. Where the point B, what should be the position of point B on the curve, so that the direction of the average velocity, it is given here. Find approximately the positions B of the particle such that the average velocity between the positions A and B has the same direction as the instantaneous velocity at B. What should be that position? One thing, at this position, at x is equal to 3 and you are looking here at x is equal to 5 here. This is the point. Here we are looking in the graph, it is given here like that. At this point, which is at x is equal to 5 meter, this position 3 meter, means at x is equal to 5 and y is equal to, at x is equal to 5 and y is equal to 3 meter, means the coordinate is 5, 3. This is the point where the direction of EB will be average velocity, direction of average velocity along AB will be same as the direction of instantaneous velocity at B. The direction of instantaneous velocity at B is the direction of the tangent, direction along tangent at B. The direction of instantaneous velocity at any point is along the direction of the tangent. At this point, the tangent is along this direction. And this is the direction of average velocity from AB. So instantaneous and average both have the same directions if the position of the particle is 5 3. This is correct answer. You should draw the graph on your graph paper, then you can find the accurate value. Okay, now question number 13. Question number 13. Question number 13. Question number 13. An object having a velocity 4 meter per second. An object having a velocity, an object having a velocity 4 meter per second is accelerated at the rate of 1.2 meter per second square. For 5 seconds. Find the distance traveled during the period of acceleration. Find the distance traveled during the period of acceleration. An object having a velocity of 4 meter per second is accelerated at the rate of 1.2 meter per second square for 5 seconds. Find the distance traveled during the period of acceleration. You can solve it by help of graph also. Let us make VT graph. Here, object having velocity 4 meter per second. Suppose this is 4 meter per second. This position is 4 meter per second. Accelerated at the rate of for 5 seconds. Suppose t is equal to 5 seconds is here. It is accelerated A is equal to 1.2 meter per second square. This point O, A and B. This is VT graph. Find the distance traveled during the period of acceleration. In VT graph, this area of VT graph, AB, suppose this is C. So area ABCO, this point indicates C. And the time here is 5 seconds. We have to find velocity. You can find velocity at point B also. If U is equal to area of ABCD, first of all write ABCO, that is equal to required distance. Now at point B, velocity v, it can be calculated as v is equal to u plus at. V is equal to u 4 plus a 1.2 into t 5, that is 4 plus, this is 6, 10 meter per second. 10 meter per second, this is the point where the velocity is 10 meter per second. Now we can calculate very easily area ABCO, area of the trapezium, that is half into sum of the parallel side OA plus AO, write like that, AO plus BC into distance OC, half into AO, it is 4 plus BC, it is 10 into OC, it is 5. "35 meter is the area. 35 meter is the distance. The area is equal to 35, that is equal to the distance. Okay, find the distance traveled during the period of acceleration. This is the answer. I think you got it. Area of VT graph is equal to displacement. Okay, and distance also in this case. Now question number 14. Let us do question number 14. Question number 14. Question number 14 says, a person traveling at a person traveling at 43.2 kilometer per hour. A person traveling at 43.2 kilometer per hour applies the brake. Okay, giving a deceleration of 6 meter per second square. To his scooter. Okay. How far will it travel before stopping? How far will it travel before stopping? How far will it travel before stopping? Now the question says, person traveling at 43.2 km per hour applies the brake, giving a deceleration. Given The velocity here, initial velocity 43.2 km per hour. You can convert into meter per second. 43.2 into 5 by 18. What will be its value? After calculation, six 3 ja 18. meter per second. Its velocity u will be 12 meter per second if you convert in meter per second. And deceleration, that is negative acceleration, minus 6 meter per second square. To his scooter, how far will it travel before stopping? X is equal to what when b is equal to 0? We know very well b square is equal to u square plus 2as. Final velocity 0. Very easy question. U is given here 12 square plus 2 into a minus 6 into s, that is x. So x is equal to here 12 square by 12, that is 12 meter. This is the answer. Okay, it was question number 14. 12 meter. Correct answer. Now come to the question number 15. Question number 15. Question number 15. Question number 15. A train starts from rest. A train starts from rest. A train starts from rest and moves with a constant acceleration. And moves with a constant acceleration. A constant acceleration of 2 meter per second square. Of 2 meter per second square for half a minute. For half a minute. For half a minute. The brakes are then applied. The brakes are then applied. The brakes are then applied and the train comes to rest. And the train comes to rest in 1 minute. In 1 minute. Find question number A. Find the total distance. Find the total distance moved by the train total distance moved by the train. B. The maximum speed attained by the train. The maximum speed attained by the train. The maximum speed attained by the train. And C. The positions of the train at half the maximum speed. The positions of the train. The positions of the train at half the maximum speed. At half the maximum speed. This is the question. Consider the meaning of the consider here what train starts from rest and moves with a constant acceleration of 2 meters per second for half a minute. The brakes are then applied and the train comes to rest in 1 minute. Find the total distance moved by the train. No need of any consideration. Only we have to think over the meaning of the question and then solve it. Now what is given? A train starts from rest. U is equal to 0 and moves with a constant acceleration. A is equal to 2 meters per second square. For half a minute, T is equal to 30 seconds. The brakes are then applied and the train comes to rest in 1 minute. This is the first journey. We can solve this question by the help of VT graph, velocity time graph. That will be more easy here. So here for velocity time graph, make a graph here. From rest, it is going like that with 2 meters per second square. Suppose O, x-axis, y-axis. And here is the point of maximum speed. The brakes and the time is 30 seconds. This time is 30 seconds. This is time axis. X-axis is represented by time, y-axis by velocity. Now, train comes to rest in 1 minute. When brake is applied here and it comes in rest in 1 minute. 1 minute from here means 60 plus 30, 1 minute, that is 60 second, that is 90 second. It comes to rest. Find the total distance moved by the train. Total distance moved by train, area of this region, that is area of this triangle. For this we have to find this maximum value. How can you calculate? OAB, let OAB. Here velocity, that is maximum velocity at A, journey from O to A. B max is equal to U plus 80. Here U 0, A 2 time T 30. 60 meter per second. This is the maximum velocity. So in first question, the total distance moved by the train, area, in first question A, total distance will be equal to area of triangle OAB, area is equal to half into base, that is 90, into height, that is this is 60 second, 90 into 30, it is, you are finding its value to be meter, 2700 meter. The question 15, the first answer of question 15A is 2.7 kilometer. It is correct. In kilometer we can write 2.7 kilometer. It is first answer. That is correct. Now the second question says, question says the maximum speed attained by the train. Automatically the maximum speed is 60 meter per second. This is the B answer. B is 60, V max is equal to 60 meter per second. Okay. Now the third one. The positions of the train at half the maximum speed. Positions at half of the maximum speed. 30 meter per second is half of the maximum speed. That means half here. Here this point will denote 30 meter per second. Let this point be any point you can assume here. A, B, you can say it's C. So at this, it is saying that when at 30 second in first journey from O to A, what would be the position, means distance, and again next 30 from here to here. Next 30 means what would be this point maximum speed here when the brake is taking place. Then the second journey, when brake is taking place. In first journey there was acceleration. In second journey after applying brake it was deceleration. Then in that case from here to here in 30 seconds, when speed becomes 30 meter per second at this point, suppose this point is D, this point is D, then what would be the value of this time corresponding to 30 meter per second at moment when velocity is 30 meter per second? What would be the time here? You can find by the help of journey from here to here. Here it was 60 meter per second, here it becomes 30 meter per second, and acceleration will be slope of this graph, retardation you can say from here. So retardation from A to B we can calculate. I want the time at moment when the velocity after brake becomes 30 meter per second. What would be that time? For this purpose, from A to D, here this is point D, for AD when brake is taking place, what would be the time from here to here? V30 U60. From journey from here to here, it will be initial, it will be final. V is equal to U, since retardation is taking place, so minus A. A is what? A is the slope of AB, that is 60 by this. Okay, A retardation here is equal to, for A to B, 60 slope of this, 60 divided by this distance, that is 60, that is 1 meter per second square. So here 1 meter per second square into V1 time from here to here. So T is equal to 60 minus 30, that is 30 seconds. So time from here to here, that will be 30 seconds, means 30 plus 30, this will be 60 seconds. This will be 60 seconds. Okay. Now it is easy to calculate the area in this case. So in first position, when the velocity is 30 meters per second, then what would be the area here? This is the area. In first case, this would be the area. This would be the area. So what is the area of this shaded region? That is area of this smaller triangle is first area. Suppose this is delta 1. This area is half into base. This time will be what? 15 seconds, because this is at mid of the 30. 15 seconds. 15 into this height, that is 30. 225 meter. In first 30 seconds, that the distance will be 225 meter, first position. When deceleration is taking place, deceleration is taking place, brake is taking place, then in that case, after 30 seconds from here, it reaches here, then what would be the area of the graph? Now in this case, the area will be this. This will be the area total. What will be the area? Find the area. Find the area of this graph. First of all, area of this. How will you calculate? We can find this area for this total area. This area plus this area. This area plus this area. Calculate first of all. This is trapezium. What would be this area? Area, suppose this is S1, this is S2. Here, what would be S1? S1 is equal to half into base 30 into height 60, 900 meter. Now S2, this area, half into sum of the parallel side, this side plus this side, 60 plus 30 into distance between both the parallel sides, that is 30. It is equal to 90 by 2, that is 45 into 30, that is 150. Now S1 plus S2 is how much? S1 plus S2 is equal to 1350 and 900. $2,250 meter means 2.25 kilometer. Okay, this was question 15. And okay, 2.25 kilometer, it's correct. So in the first case, when it was 30 seconds in the beginning of the journey, 250 meter, and while reaching here, it will gain the total distance, that is 2.25 kilometer. This is answer. Okay. Now let us move towards next question, 16. Question number 16. Question number 16. Question number 16. Question number 16. A bullet traveling with a velocity of 16 meter per second. A bullet traveling with a velocity of 16 meter per second. 16 meter per second. Okay. Penetrates a tree trunk and comes to rest in 0.4 meter. And comes to rest in 0.4 meter. Find the time taken during the retardation. Time taken retardation. What is given? A bullet traveling with a velocity of 16 meter per second penetrates a tree trunk and comes to rest in 0.5 meter. Speed is given 16. Initial speed u is equal to 16 meter per second. Comes to rest. Final velocity becomes 0. And time and distance covered s is equal to 0.54 meter. Then t is equal to what? Suppose this is the tree trunk where bullet is just fired and it comes to rest here in s distance. So you can apply v square is equal to u square plus 2as. 0 is equal to u square 16 square. Since it is coming to rest, so retardation takes place. So 2 into a. A is how much? Not given. Into s. S is given 0.4. Now 0.8a is equal to 16 into 16. So a is equal to 16 into 16 by 0.8 means 8 by 10. 10 will come above. It will be 320 meter per second square acceleration. We want time. V is equal to 0 plus at, u plus at. 0 is equal to u is 16 and retardation is 320. So t is equal to Okay. Sixteen by 32 into 10. It is 1.2 into 1 by 10. Okay. It is to 16 to the 32. 1 by 2 into 1 by 10. 0.5 by 10 means 0.05 second. 0.05 second is the time. That is the answer. Very simple question. You can solve it easily. Question number 16 now. Question number 17. Question number 17. Question number 17. A bullet going with speed 350 meter per second. A bullet going with speed 350 meter per second enters a concrete wall and penetrates a distance of 5 centimeter. Distance of 5 centimeter before coming before coming to rest. Find the deceleration. Find the deceleration. A bullet going with speed 350 meter per second enters a concrete wall and penetrates a distance 5 centimeter before coming to rest. It is the same question as earlier, 16. Find the deceleration. U is equal to suppose 350 meter per second, enters concrete wall and penetrates a distance of, suppose s is equal to this 5 centimeter means 5 by 100 meter. Before coming to rest, v is equal to 0. Find the deceleration, a is equal to 1. Okay. So now v square is equal to u square plus 2as. V square 0. U square 350. Deceleration, a will be negative. You can put sign here. 2 into a into s. 5 by 100. So 5 by 100, that is 10 by 100. A by 10 is equal to 350 into 350. A is equal to 350 into 350 into 1000. Okay. Now you can calculate The answer after calculation would be 12.2 into 10 power 5 meter per second square. You can calculate it very easy. 12.2 into 10 to power 5 meter per second square. You will get this value. You can check it. Now question number 18. Question number 18. Okay. Question number 18. Question number 18. A particle starting from rest. A particle starting from rest moves with constant acceleration. Moves with constant acceleration. If it takes 5 seconds to reach the speed, if it takes 5 seconds to reach the speed 18 km per hour, to reach the speed 18 km per hour. Find A. The average velocity during this period. The average velocity during this period. B. The distance traveled by the particle. The distance traveled by the particle during this period. Solution. The particle is starting from rest, moves with constant acceleration. If it takes 5 seconds to reach the speed 18 km per hour, find the average velocity during this period. You can draw a VT graph. At t is equal to 5 seconds, it is reaching with speed 18 km per hour. You can convert 18 km. 18 into 5 by 18, that is 5 meter per second. So 5 meter per second will be the velocity here. The first question A. The average velocity during this period. Average velocity during this period. There is an acceleration, constant acceleration. In VT graph, this is the area. Total area will be distance traveled by the particle. So first of all, the displacement here from OAB, area OAB is equal to half into base into height, that is 5. 25 by 2, 12.5 meter. This is the displacement as well as the distance, both 12.5. Now average, we want the average velocity. Average velocity is total displacement. This is displacement here. Total displacement by total time. Total displacement is 12 by 0.5. Total time is 5. That is 2.5 meter per second is the average velocity. And total here distance, this displacement will be distance also, because in a straight line the motion is taking place here. There is a acceleration. So the second is total distance, that is 12.5 meter. That is the answer. Question number 18, you can check. 2.5 meter per second, correct. In second, 12.5 meter. Okay. Now question number 19. Let us do question number 19. I think you got it. Question number 19. Question number 19. It says a driver takes 0.20 second. A driver takes 0.20 second to apply the brakes. After he sees a need for it. After he sees the need for it. This is called the reaction time. The reaction time. This is called the reaction time of the driver. Okay. If he is driving a car, if he is driving a car at a speed of 54 km per hour, and the brakes cause a deceleration of 6 meter per second square. Find the distance traveled. Find the distance traveled by the car after he sees the the need to put the brake on. The need to, after he sees the need to put brake on. Find the distance traveled. Actually, driver takes 0.20 second to apply the brakes after he sees the need for it. This is called the reaction time. When you see anything just in front of you, then automatically to on the brake, there will be a time. That delay of time after seeing anything in front of you, that is the reaction time. So this is called the reaction time of the driver if he is driving a car at a speed of 54 km per hour. Suppose speed is u is equal to 54 km per hour. That is 54 into 5 by 18, 15 meter per second. Brake is with deceleration 6 meter per second square. Find the distance traveled car after he sees the need to put the brake. First of all, we see that suppose driver takes 0.20 second to apply the brakes after he sees the need for it. 0.20 time, this is the reaction time. In this reaction time, the distance covered by 15 meter per second is how much? Suppose here he sees driver, what is saying? The driver takes 0.20 second to apply the brake after he sees the need for it. Driver just see any person, any car, anything. Then 0.20 is the reaction time, and this reaction time will be covered. This reaction time is the time where the speed is 15 meter per second. Means for this time the speed will be constant 15 meter per second. So this distance will be, suppose x is equal to speed 15 into 0.20. For this time, this speed 15 meter per second will be the uniform speed from here to here, x. And then from here brake is applied from here. So this is the distance covered in 0.20 second. That is the reaction time with 15 meter per second. So this is how much? 3 meter. So this distance is 3 meter. Now brake is being applied from here. So here the initial velocity will be 15 meter per second and the final velocity will be 0 here. So this distance is suppose s. So v square is equal to u square minus 2as v square, that is 0, u square 15 square minus 2 into a is given 6 into s is what? Here you will calculate s is equal to 15 into 15 divided by 12. Okay. 3 4 ja 12. 70. Okay, s is equal to here 15 into 15 by 12. So 3 4 ja 12, 3 5 ja 15. 15 into 5, 75 by 4. This is the distance. Okay. What will be the distance? 75/4. It is 18.88 means suppose S is equal to, that will be 19, approximately 19 meter. So S will be 19 meter. So this will be X is equal to 3 meter and plus this is 19 meter, approximately 22 meter. That will be the distance traveled by the car after he sees the need to put the brake on. Okay, I think you have got it. From 20 onward question I will do in the next video. Till then, do hard labor and practice and do practice.